So what are the first order differences here?
1, 9, 19, 43, 69.
Careful on like here, 21 minus 2 is the 19, but you want to take the difference. So you'll take negative 2 minus 21.
23.
Yeah. Okay, so first order differences are all different. So this is not a linear equation. So let's move to the second order. Okay, when we take the second order differences, from 1 to 9 is 8. From 9 to 23, 14. 23 to 43, 20, 43 to 69, 26. Okay, so all of these are different, so it's not a second degree or second order. So it's not a quadratic equation. Let's go to the third order. 8 to 14 is 14 to 6, or 20 is 20 to 6, 26 is. So we finally found our consistent differences. So we have a third order. Remember, third order is equivalent to which type of regression? Cubic. And so now we can go back to our calculations here. Change our C2 values. So negative 12, negative 11, negative 2. 21, 64, and 133. Okay, so there's our functions. We can now go into our Calculate tab, change this to the cubic regression, which is what we are expecting. Our C1, C2 align with the x and y coordinates. We can just copy it into, again, our y editor here. And so when we do that, we get our equation of f of x equals 1x cubed minus 2x squared. Now, notice I have a 0. If you have a 0 and you have to enter this online, should you put 0x on this? No, just leave it blank. Okay? So then we have a minus 11. Oops. And then the 1 tells us the reliability coefficient is 1, which means we're right on. This is an accurate equation for that data set. Hey, Mark.
So when you're going through and like if you enter it in as like on the last problem we did, I entered it in like into the wrong like regression.
It will give you a formula for it. Let's take a look at what happens. So let's say we go back into this, and let's say you just guessed on this one because you were too lazy to go through these steps. And let's say you thought it was quadratic. It's still going to give you an equation for that, but it's going to be wrong. Now, again, even though on here it has a relatively high reliability coefficient, it says that it's 0.996. I mean, it's 99% accurate within that set of data, but it's going to give you the wrong set because it thinks that you're looking at a parabola rather than something that's going to kind of S curve. Jack, was that your question too? Jack?
Yeah, it was with the, so I know you don't use the 0, but if you have like the negative 11 and the negative 1, or I remember because on my last one is a 1, so like, you just don't use it?
That R squared. Remember, that's called reliability coefficient. The closer it is to 1, it pretty much is a percentage. So this value right here, when I did quadratic regression for this same set of data, it gives me an equation that fits this data with a 99.6% accuracy. However, when we use the cubic regression, we got a value of 1, which is 100% accuracy. Okay, so you want that to be close to 1. The closer it is to 1, the more likely it is to be accurate for that.
So why wouldn't the negative 11 be negative 11x? Use 0?
Yeah, the 0 is basically 0x minus 11, but don't write the 0x when you're entering your answers online. Just leave it blank.